Hi, college algebra students. This is our very last video. This is our study guide for the final exam. And so I've posted the blank one on Blackboard as well as my completed one on Blackboard. But I think that it would really help you if you just went over this video with me, if you just watched this and we kind of did it together step by step. So the final exam is going to be different than it ever has been before because, of course, it's online. So it will be in my math lab. It'll be the only assignment available to you. It will be multiple choice, and it will be 30 questions. Now, the study guide is more than 30 questions, and some of these questions look very similar to each other, which I know may seem a little strange, but the way they're doing it is there's a pool of 93 college algebra questions. And out of the 93 questions, each of you will be assigned 30 randomly. And so everyone could have a different test. And so in an effort to just make sure that you're fully prepared, I made sure that one of every one of those 93 problems ended up in the study guide. So I tried to pare it down. This is 42 questions, but this should completely prepare you for whatever questions you get on your final. So let's jump right in. Here we go. Your first question is find the quotient. So if you notice, this is a complex number. There's a real part and an imaginary part, and you can't divide those. So what you have to do is multiply the top and the bottom by the complex conjugate. So remember, the complex conjugate is just going to be the denominator with the middle sign changed. That's it. So what we're going to do is multiply the top and the bottom by 2 plus 6i. Okay, so just the denominator's complex conjugate. Then we're going to FOIL everybody out and clean it up. So we're going to get in the numerator 12 plus 36i plus 4i plus 12i squared. Okay, in our denominator, we're going to get 4 plus 12i minus 12i minus 36i squared. Okay, so in the denominator, those are going to cancel as they should. Let's clean this up a little bit. In the numerator, we're going to have a 12. Let's combine these terms. 36i plus 4i is a plus 40i. We know plus 12i squared is actually minus 12. And that's going to cancel with that plus 12. So we are already really reducing. Okay, down here in the denominator, we're going to have 4 plus 36i squared, minus 36i squared is the same as plus 36. Okay, so if my numerator is 40i and my denominator is 40, we can reduce these and we should end up with, you know what, this 40 is supposed to be a minus. What did I do wrong there? Let's see. And we get I. How did I end up with a minus I as my answer when I did it before? Let's see. Let me just go over this one more time and make sure I didn't do anything strange. That looks right to me. I'm not sure. So maybe I made a mistake on the study guide and maybe it's just a positive I that I came up with. I thought I had gotten a negative I. So go through there and see what you think. But to me, when I'm looking at it right now, it looks like a positive I to me. Okay, so number 2, solve the equation and check all the solutions. Well, this has a radical in it. We want to isolate that radical. And it wouldn't hurt if he was positive. So what I'm going to do is add this guy to this side, and I'm going to add this guy to this side. Okay, so I'm just going to rewrite it. so that I have x plus 6 on the left, and I have the square root of 2x plus 15 on the right. Okay, so I just rearranged my terms. I added my 6, I added my radical. Okay, next thing I'm going to do is I'm going to square both sides. Since I have a square root, that's going to pop that root right off of there. Now remember, this left side, this means I have 2 of these. So that's what I'm going to end up with. Okay. All right, I'm going to FOIL on the left, and I'm going to get x squared plus 6x plus 6x plus 36. And the 2x plus 15 on the right. Okay, combine my like terms. I get x squared plus 12x plus 36 equals 2x plus 15. Okay, I'm going to come over here now. Now, I'm going to combine these terms over to here. So I'm going to subtract my 2x, and I'm going to subtract my 15. And so I should end up with x squared plus 10x plus 21 equals 0. All right, I have a leading coefficient of 1, so all I'm going to have to do now is factor. Okay, so I need factors of 21 that are going to add together to give me 10. Well, that would be a positive 7 and a positive 3. That would do it. Okay, solve both of these, and these are my 2 answers. Now here's where it gets interesting, because you will have an answer choice with both of these on there. You will have an answer choice with just this one. You will have an answer choice with just this one. And you're also going to have one that is no solution. Look at these directions. Check, 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 check. Remember, when you square a square root, you have the chance of coming up with an extra solution, an extraneous solution. So we have to go back and check both. You're going to want to put both of these one at a time back into the original for x and see what you come up with. Okay, I'm going to let you do that on your own since this is such a long study guide. But what happens is that -7 is not going to work, but -3 is. So make sure on your test with this problem, I believe there's a version where both work. I believe there's a version where only one work, and there may even be a version where none of them work. So please make sure that you are checking. This is the only tricky one like this until we get to logarithms. The logs have one like this as well, okay? All right, number 3 just says solve. Well, this looks like a quadratic, so I'm going to get all my terms on the left. There we go. Okay, now normally I would try to factor this. If I was going to try to factor it, I would have 3 times 2. That would give me a 6. I would go through my factors of 6 and come up with something that multiplied together to give me 12. But as you can see, that's not a possibility. So I'm going to have to use quadratic formula for this guy. Some of them factor, some of them don't. Okay. All right, so if you recall, your quadratic formula looks like this, right? Okay, and then my A is 3, my B is 12, and my C is 2, okay? Now all I'm gonna do is plug it in and see how far I can go. All right, so negative B, or opposite of B, is -12, plus or minus B squared, that's gonna be 144, minus 4 times 3 times 2, all over 2 times 3, okay? It's gonna give me a -12 plus or minus, this is gonna be 144 minus a 24. That's gonna give me a radicand of 120, all over 6. Now remember, I cannot break into here and reduce. But I do need to check and make sure that I can't reduce the square root of 120 because I think I can. So if you already know how to reduce him, you go right ahead. If you're not sure, come over here and make your little factor tree. I know 12 times 10 is 120. And then I know 12 is 6 and 2. And I know 10 is 2 and 5. I'm going to continue to break down until I have all prime numbers and make sure these all multiply back to give you the 120. All right, I'm looking for groups of 2 numbers that are the same. Well, I'm just going to grab these 2 right out of the middle. That comes outside. I don't have any others that have a group of 2, so now I'm just going to multiply them together and put them back under. So 2 times 3 is 6. 6 times 5 is 30. So what I really have is negative 12 plus or minus 2 root of 30 all over 6. Now I can reduce because I have this magic triangle. And the smallest factor I see at a corner is a 2. So I'm going to divide every corner by 2. And I get negative 6 plus or minus root of 30 all over 3. Now I know that's tempting to try to pull out a 3 there, but remember you're not allowed under the radical. So you're done. And that's your answer. Okay, that's your answer. So remember this number 1, I had made a mistake in the back. I'm going to send you an email about him. I had put negative I, and I keep looking back over. You can't see me off camera, but I'm looking back over at my answer sheet, and I have no idea where that negative came from. So I think my answer has to be positive I. So I will send out an email regarding that one. Okay. All right, number 4. Find a rational zero of the function and use it to find all the zeros. All right, well notice here what I did is I went ahead and put in multiple choice answers because this is one of those big giant polynomials from section, I think it was 3.4. Remember those? We were supposed to use the rational zero theorem and find possible rational zeros. We were supposed to do synthetic division till we find one. Then we're supposed to knock that down, but this is a 4th degree, so we'd have to do that twice. It's just a huge problem. So what we're gonna do is we're gonna be smart about our answers. We're gonna be smart, and I'm gonna show you how to do that. So, all right, I'm not interested in these directions. All I wanna find are the answers. And here are my choices. And this is a 4th degree, so I know I have 4 answers. Now, I have nice little 1 or negative 1 as a choice for each. And I have a nice little 2 or negative 2 as a choice for each. And then it gets irrational. Then it gets crazy. I'm not worried about these. They're too hard to check. They're too hard to come up with, so I'm not worried about them. What I'm worried about is negative 1 or 1 and 2 or negative 2. What I'm going to do is use the remainder theorem. I'm going to plug in a negative 1 to this polynomial and see if I get 0. Okay? If I do get 0, then I know it's a solution, and I know that is one of my answers. Okay, so I'm going to plug in the negative 1. There we go. Put this right in your calculator. Go through it. Be careful with that negative. Guess what you come up with? 0, which means negative 1 is in fact a solution. So I don't want B because B doesn't have a negative 1. And I don't want D because D does not have a negative 1. So I've already cut my answer choices down by 2. I've already cut them in half, okay? So we know negative 1 works. Those are the only 2 that contain negative 1. Now let's go to our next answer. Letter A, choice A, has a 2. Choice C has a negative 2. All right, so now what I'm going to do is take that positive 2, and I'm going to plug it in and see what I come up with. See if I have a 0. If I do, then I know it's A. Okay, so as I go through here and I complete that, unfortunately, I don't get a 0. I get a negative 144, which means that 2 is not one of my answers. I can cross that off. So by process of elimination, C has to be my answer. But let's just make sure. Let's make sure that negative 2 is in fact one of our zeros. So I'm going to go through the whole thing again. I'm going to put in a negative 2 this time. Okay. When I do that, guess what I come up with? 0. It is a 0. And it is the only, C is the only answer choice that contains a negative 1 and a negative 2. So I'm not worried about these other irrational choices. I'm going to choose C. So that's the quickest, best way for you to work a problem like number 4 that you're going to see on the test. It's really just process of elimination. Okay. All right, number 5. Complete the square and write the equation in standard form. This is a circle, and we want it to turn into a circle in standard form with our center and our radius squared. That's what we need to do here. And then we need to tell the radius and our center. So here we go. We're going to put the x terms side by side and leave a little blank. Then we're going to put the y terms side by side, leave a little blank. Now 32 is the constant. He doesn't have an x or a y, so he's going to need to go to the other side. So because he's being added here, I'm going to subtract him. And then because I added 2 blanks on the left, I'm going to add 2 blanks on the right. Okay, so this is important. We set it all up. All right, what goes in the blanks? Well, what goes in the blanks is b divided by 2 squared. That's what's going to fill in the blank. Hopefully that rings a bell to you. So, first blank. My b is negative 8. I'm going to divide it by 2 and square it. That's going to give me a negative 4 squared is a 16. Okay, notice I put it in each of the first blanks. Now I go to the next blank. I'm going to have negative 10 divided by 2 squared. That's a negative 5. Square becomes positive 25. Put it in those blanks. Now we have completed the square for x and for y, and we're ready to put it into this form. So here we go. I'm going to have a parenthesis squared plus a parenthesis squared, and then I need to clean up the right side. When I add all these together, I come up with a 9. Okay, so what are we going to put in the blanks? Well, here we go. We're going to have square root of the first term, sine of the middle, square root of the last term. Square root of the first term, sine of the middle, square root of the last term. There's our equation. Okay, now we want a center, and because the standard form automatically has minuses in here, all we need are the numbers for 5. And our radius, we take the square root of the number on the right, is a 3. And those are our pieces of information. Okay, so make sure that you're comfortable doing that you can get all those pieces of information. Okay, let's look at number 6. Number 6 wants the x-intercepts of the polynomial function. These are the same as the zeros. And state whether they cross the x-axis or touch and turn. So remember, this has to do with the multiplicity, right? Okay, they're going to cross if your multiplicity is odd. They're going to touch and turn if your multiplicity is even. And remember, your multiplicity is just the exponent on the outside of the factor. Okay, so here we go. Now in this case, I have something sitting outside here. So hopefully you remember, if you do, that just becomes x is 0. If you want to see that worked out, you set the whole thing equal to 0, just like that. I would divide both sides by -2. I still get 0. Take the square root of both sides, still get 0. There's my x-intercept. Or you can just remember that if it's outside like that, it's going to be 0. Now, his multiplicity is a 2, which is even. That means he's going to be a touch and turn. Okay, next packet. X minus 9. If I solve that, or x plus 9, I get x equals -9. He's got a 1 here. That's an odd multiplicity. That's going to be a cross through. Okay, and then this guy over here is secretly a difference of squares. So I'm going to have x is -2 and x is +2. And notice that their multiplicities are also 1, which is odd. So these are going to be cross throughs. And there we go. We have all 4 zeros and exactly what they do based on their multiplicity. Okay, number 7, use synthetic division to divide. All right, so on the test, you're going to have a synthetic division problem. You will not be missing a term. Notice we're not missing a term either. You will have an ugly remainder. So let's jump right in. Okay, we're going to put the coefficients first. So 1, -3, -7, -14, -5. Now we need something to go in the shelf. If I solve this for x, x is going to be a +4. And now I'm going to add these, but I'm going to bring down my first number. So I'm going to have 4 times 1 is 4. -3 plus 4 is 1. 4 times 1 is 4. Add those, we get -3. 4 times -3 is -12. Add, we get -26. 4 times a -26 is a -104. Add those and we get -109. Okay, now we need to write this as a polynomial. We had a 4th degree, which means our answer is going to be a 3rd degree. So x cubed plus x squared minus 3x minus 26, here's my remainder, minus 109 over the entire denominator, x minus 4. And there's my answer. Okay. All right, let's talk about vertical asymptotes. To find the vertical asymptotes, first thing you're going to want to do is factor, and then set your denominators equal to 0. Okay, so let's factor this guy first. We have 2 little problems here to do. This denominator is a difference of squares. So there, we factored him. Just so happens this denominator is also a difference of squares. Okay, so depending on which version of the test you get will depend on which type of problem you get. We briefly discussed the fact that if your numerator and your denominator cancel, that's not a vertical asymptote. That is a whole. And in this case, these cancel. X equals 3 is a whole, not a vertical asymptote, so we do not pay any attention to it. We ignore it. The only vertical asymptote this particular function has is x equals -3. And that's because the top and the bottom cancel. This doesn't have anything to cancel. We ignore the numerator since it can't cancel. And here you have 2 vertical asymptotes. -5, and +5. And that's your answer. So be careful. I don't know which version of that you'll have on the test, and we want to make sure that you get that correct. Okay. All right, let's talk about horizontal. There's 3 possible answers for horizontal asymptotes. Let's do all 3 depending on what kind of test you get, right? In this situation, they have the same degree polynomial. They're both second degrees. So all we are going to do is put y equals these coefficients, 8 divided by 3, and we're done. Okay, that's if your degree is the same. Okay, now let's look at g of x. In this case, the degree of the numerator is larger than the degree of the denominator. When that's the case, we say that there isn't a horizontal asymptote. There's none. And in the last case, h of x, the denominator degree is larger than the numerator degree, which gives us y equals 0 for that one. So 3 possible scenarios there. We want to be careful with all of those. All right, number 10 is a long one. It's a long problem. We want to make sure that you're comfortable doing this. This is the one, because you have the inequality, where you have to test. Remember, you have the intervals and you have to test a point in each interval and see if it's true. You will have one of those. So first thing we need to do is solve this for our boundary points. So if I do 2 times -7, I get -14. So one factor will be positive, one factor will be negative. Here are my choices. We want them to add together to give me a -5, which means the 2 and the 7. Okay, we're just going to replace -5x with those two. All right, we want a -5, so put the negative with the bigger. So we're going to have plus 2x minus 7x minus 7. There we go. We're going to group. I see a GCF of 2x that I'm going to pull out, and I get an x plus 1 inside. I see a GCF of a -7 I pull out. I get an x plus 1 inside. Those are both the same. I pull it out, and I write what's left in my second parenthesis. And there we go. Now, this solves down to x is -1. This solves down to x is a positive 7/2. These are not the answers. Remember, these are the boundary points. So, -1, 7/2. I have now created 3 intervals. All right, so I'm going to make a little chart so that I can test my points with. Okay, I'm going to come up with a test point for each. I'm going to do a little evaluate here, and then I'm going to draw a conclusion. Now, you don't have to do this. All you have to get is the answer, but this just kind of helps keep it straight in my mind. So I have 3 intervals. I'm going to need 3 rows. Okay, my first interval is going to be from -infinity to -1. Now, what kind of boundary is -1 going to get? I have to come up here. This means a hard bracket. So that's what it gets. You will not have any of those rational expressions where you have to be careful with the numerator and the denominator, and sometimes it's a parenthesis. You don't have to worry about those. So this interval looks like this. Okay, next interval, -1 to 7/2. And again, these are hard brackets because of this. Some tests will have hard brackets, some tests will have parentheses. You will not have a mix of both, okay? All right, so here we go. And then last but not least, our third interval. Okay, so we need to come up with a test point in each. So in this interval, a test point that's less than -1, I'm going to say -2. For this one, you know I love a 0. I'm going to throw in 0. Now this one can be confusing because what in the world is 7/2? Can I just say +2 or +3? Well, not really. 7/2 is actually 3.5. So you want to be bigger than 3.5. So I'm going to say 4. Okay. All right, now we're going to evaluate. We're going to take each of these and put them into this inequality and see what we get. So I'm going to put a -2 in for x and see what I get. I ended up with an 11. In order for this interval to be part of my answer, this has to hold true. Is 11 less than or equal to 0? No, of course not. So that is not correct. That interval is not a true interval. Okay, let's try 0. Put that into my polynomial there, try it out. I get -7. Is -7 less than or equal to 0? Yeah, perfect, that one works. Okay, I better check the last one just in case. I'm gonna put this 4 in, make sure it works. It ends up being a 5. Well, 5 is not less than or equal to 0, so this interval does not work either. So my answer is this interval. That's my answer. You, depending on what kind of test you get, will either have one interval, like we do, or both of these intervals on the outside. And remember, if you have this one and this one, do you remember how we connect them? We do that with the big fat bottom U, correct? That's what we do, so we want to make sure you're comfortable with that. Now, it says we also want to graph it. On my math lab, you'll just have to pick the graph that matches. So if this is my graph, all I want to do is pick the graph that shows this little interval right in the middle with the hard brackets. And that's my answer. Okay, just like that. So if you don't need to do all of this, you certainly don't have to. This is the answer. But this is a really nice, concise way of coming up with that answer. Okay. All right, let's get into some logs now. This was chapter 4. Okay, number 11 says to use the properties to expand the log. All right, well, we know if we have items multiplied together in the argument, we can separate them and add them. If we have items being divided in the argument, we can separate them and subtract them. So here we go. We're going to have log base 4 of x squared. We're going to add that to log base 4 of y to the 6. And we're going to subtract log base 4 of z cubed. Now we're not done. We can't have exponents in here. These are going to be moved to the front as coefficients. So your final answer is going to be 2 log base 4x plus 6 log base 4y minus 3 log base 4z. That would be what you're looking for. Okay. All right, number 12. Solve the equation and reject any value not in the domain. Could also be ln. ln is in the natural log. In case you don't see log, in case you just see ln, same situation. Okay. Well, since I notice these have the same base and they're subtracted, I'm going to rewrite that as a division. Now, the reason I'm doing that is because now that I have log equals log, I can cancel these out. And I'm left with just this argument equals this argument. Now I'm just going to solve for x. So I'm going to multiply both sides by this denominator because I'm trying to get rid of it. This is going to cancel. I'm left with 5 plus x on the left, and I'm left with 5 times x minus 3 on the right. Okay, I'm going to distribute. I'm going to get 5 plus x equals 5x minus 15. And now I'm just going to solve. I'm going to subtract x from both sides. And I'm going to add 15 to both sides. I get 20 equals 4x. Divide by 4. And I get a 5. All right, now before I circle it and move on, I need to know, is that possible for the domain? So I take 5 back up here to x and I plug it in. 5 plus 5 is 10. That works. What I'm checking for is to make sure the argument is a positive number. If it's not, I have to get rid of this and say no solution. When I plug 5 in here, I get 5 minus 3. That's a 2, still positive. So he works. Okay. All right, find the domain. Okay, these are the same problem. Notice this is a log with a base. This is ln. Again, some of your tests are going to use a lot of ln, and I just don't want you to get confused by that, but this is going to be the same answer either way. So regardless of which one you use to find the domain of the function, you take the argument, x plus 5, and set it greater than 0. Only greater than. We don't want it to equal 0. We're going to solve this and get x is greater than negative 5. It's going to want it in interval notation. So if we want to be bigger than negative 5, we are looking at negative 5 to infinity. And that's our answer. Okay. All right, number 14, solve the equation. Now, some versions of the test want the solution set in terms of natural logarithms, that's ln. Some versions of the test want you to put it in your calculator and have a decimal to 2 decimal places. So we're going to do both because I don't know what version you're going to get. But if we want to solve it with ln, then we're going to take the ln of each side. Okay. Now the reason we would do that is because the super secret base is an e. That's going to cancel, and you're going to get x plus 5 equals the natural log of 7. Then if I subtract 5 from both sides, I'm going to get x equals ln of 7 minus 5. And that's my answer. Remember, I cannot combine these because they're separate. All right, if I were to give a decimal approximation, I would still have to solve it. I still have to have this. But now I'm just going to put this right side in my calculator. So here we go. I'm going to put in ln of 7 minus 5. And then I would write negative 3.05. Okay. So regardless of which one of these you have, you still have to solve it. It's just if you have the calculator, put this into your calculator and come up with that. And that's your answer. Okay, now we have some little word problems here, which I just know you love, but let's make sure you're comfortable with them. So 15 comes from section 4.5. It gives you a model of decay, okay, an exponential model. All you have to do is identify what you're looking for and what these given numbers are. So this models the amount of a particular radioactive material stored in a concrete vault. X is the number of years since the material was put into the vault. So X is years. 600 pounds of the material are initially put into the vault. Well, that's AO. That's the original amount. How much time will need to pass for only 231 pounds to remain? You are solving for T in this case. So here we go. We're going to have 231 equals 600 times e to the negative 0.00866x. All right, what we want to do is isolate that little e number. So I'm going to divide both sides by 600. Okay, 231 divided by 600 is 0.385. Okay, just like what we were dealing with over here, the only way to get that x out of the exponent is to take the natural log of both sides. So I'm going to take the natural log of 0.385 and the natural log of the e stuff. Okay, so remember, it's super secret base of e there. This cancels. What we're left with is the ln of 0.385 equals negative 0.00866x. Okay, then I'm going to divide both sides by this number. My x is going to be ln of 0.385 divided by this number, this coefficient. Put that into my calculator. Okay, I'm going to have the ln of 0.385 divided by negative 0.00866. I'm going to round, and I'm looking at 110 years. That's my answer. Okay, so we did a problem very similar to this in section 4.5, but this is just a little reminder to you. All right, number 16 is an oldie. It goes all the way back to the first day of class. So here we go. A bus fare in a city is $1.25. Okay, that's every time that you ride the bus. It's $1.25 times X, however many times you ride it. People who use the bus have the option of purchasing a monthly discount pass for $15. With the pass, each fare is only 75 cents. Determine the number of times, which would be X, in a month, the bus must be used so that the total monthly cost without the pass is the same as the total monthly cost with the pass. Okay, so this is without the pass. It's $1.25 times X. With the pass, you have to pay $15 up front and then 75 cents every time you ride the bus. So we set it up. Now all we're going to do is solve for X. I'm going to subtract 0.75x from each side. I get 0.50x equals $15. Divide by 0.5, and x equals 30. You'd have to write it 30 times for it to be the same. Anything over 30, it would be cheaper if you went with the pass. Okay, number 17. So it gives you this function which shows the relationship between the number of pizzas sold, that's X, and the profit that's made. Find P of 500, the profit made from selling 500 pizzas. Well, all it wants you to do is put in 500 for X. And if you put in 0.93 times 500 minus 60, 405 is your profit. Okay. All right, moved on to 18. Okay. So here we are going to graph the equation. Okay. We have a graph up here. Now we're going to need to solve for y because we want it in mx plus b form. And I didn't write on here the directions, but we also want the y-intercept and we want the slope. Okay. So I'm going to leave my y term and I'm going to subtract my 4x and my 6 all to the other side. Then I'm going to divide each term by negative 6 and I get y equals a positive 2/3 x plus 1. Okay, now I can graph that. What this tells me is that my y-intercept is 1, 0, 1. My slope is 2/3, which means I'm going to go up 2 and right 3. So here's my y-intercept. From this point, I'm going to go up 2, right 3. All you're going to have to do, pretend that went through there, you know I'm a terrible grapher, is pick the one that's correct. You'll have 4 choices. Okay. All right, number 19. It's supposed to say 19, it says 9. Okay, solve and reject any value not in the domain. So remember, we're gonna have to check our domain. All right, well, I only have 1 log here, so I'm gonna have to rewrite this in exponential form. So I'm gonna take my base, raise it to the other side, equals my argument, x plus 2. 3 to the 5th happens to be 243 equals x plus 2. Subtract 2 from both sides, and x is 241. Now I went ahead and circled it. I probably should have waited and put it in here and checked it, but I knew if I added 2, it's certainly not going to make it negative, so I'm good. Okay, number 20. Okay, number 20 says to graph the square root of x with a solid line. Now you're going to have 4 choices, so you don't have to graph it, but just know that the absolute value of x looks like this, right? It's like a sharp V that comes right off the origin, just like this. Okay, now depending on which test you get, this is what you could end up with. So I have 4 other graphs. We are going to go through and graph each one of these so that no matter which version you get, you're comfortable with it. And we're going to graph it with a dotted line. Okay, so remember with transformations, hippos seem really violent. Remember our little saying there? Horizontal, stretch or shrink, reflect, vertical. Okay, let's do g of x first. Here's g of x. What am I looking at here? I have a horizontal of 3, so I have 3 to the right, because remember, minus 3 means to the right. Then I have a reflection, and because it's outside of the whole thing, I'm reflecting over the x-axis. So instead of I'm going to start here at the origin, but then I'm going to go right 3, and then instead of going up, I'm going to go down because I have reflected. So if this is your version, this is the graph you choose. Okay, let's try h of x. This might be the version you have. We're still going 3 horizontally, but now we're going 3 left. And that negative says reflect over your y-axis. So now we're going 1, 2, 3 to the left, and we are reflecting down. And that's the one that we're looking for. Okay, all right, let's try k of x. Okay, in this case, I don't have anything horizontal. I do, however, have a 2 out front. Now, what in the world does that 2 mean? That 2 means we are going to be twice as steep, which means we're going to become narrow. So instead of being so far out, we're going to come in more. We're going to be twice as narrow, twice as steep. And then this plus 3 on the whole thing means 3 up. Okay, so we're going to go in and we're going to hop up, all right? So what we're looking at is one that looks like that. Okay, be careful with these numbers out in front there. All right, P of x. P of x has 3 things happening. We have a horizontal. So we're going to go 3 right. 1, 2, 3. Okay. Then we have a stretch or shrink there. We're going to be a third as steep, which means we're going to be wider. And then we're going to go up 2. So we're going to be up here, and we are going to be very, very, very wide, just like that. Okay. So make sure you're comfortable with these and that you know which graph it is that you're looking for. Okay. All right, let's go on, look at number 21. Okay, number 21 says determine which two functions are the inverses of each other. Well, here's how you're going to know that. You're going to make composites. Inverses make the composite X. They make the composite X. So when we put one of these inside the other, it should quickly and easily simplify down to nothing but X. That's how you're going to know which is the inverse of the other. Okay. All right. So let's try putting F. Let's do F of G. This means I'm going to take G and put it inside of F. So I'm going to take x cubed minus 2 and put it right in there. I would be cubing the whole thing, and then I have a plus 2. Well, hopefully you can see right away this is not going to make it simpler and turn it into an x. It's only going to get more complicated. So that's not going to work. Let's try f of h. Okay, let's put h into f. All right, that means all of h gets cubed and added to 2. Now this just might work. Let's see what we have here. If I cube a cubed root, all of that pops off and I get x minus 2. Then I still have plus 2 hanging around. Those cancel. Sure enough, I get just an x. All right, now we have one that works. That means the other thing that has to work is it has to go the other direction. I have to be able to put f into h also. So let's try that. Okay, here's my h. I'm going to put f into that. I'm going to have x cubed plus 2 minus 2, all under the radical. Well, these 2's are going to cancel, and the cubed root of x cubed is x. That works also. So f of x and h of x are inverses of each other, and that's how I know. Okay. All right, number 22. We want to identify the intervals where we are increasing, decreasing, and constant. So this takes care of 3 questions in itself. One version of the test is only going to ask for increasing. One version is only decreasing. One version is always constant, only constant. So remember, we're only interested in x values only, and we're only using parentheses. That's it. Okay, so here we go. I'm going to start over here, and immediately I notice I'm decreasing. Okay, so these should really have little arrow tips on them. Okay, so x values only, I'm coming from negative infinity down to -3. I was decreasing. Now from -3 to +3, I'm constant. And then from 3 to positive infinity, I'm increasing. And those are my answers. All right, number 23. Find the composition for the given function. So this is really similar to the one we just saw about the inverses. Okay, here's the composition it wants. And remember, you always read this from right to left. So we're going to take f and put it into g. Okay, So here's my G, and I'm putting F into it where my X would be. Well, that cancels. These cancel. I'm left with just X. Turns out these guys were inverses. We didn't even know that, but there you go. All right, number 24. Solve the equation. Okay, so we don't know if this is going to be a factor or a quadratic formula. So here we go. We're just going to try it out. I'm going to multiply those two together. I get negative 21. Okay, here's my possible factors. One's going to be positive, one's going to be negative, and they need to combine to give me 4. Turns out I can factor him just fine. Okay, so I want a positive 4, which means I'm going to take a positive 7. Now notice I put the 7 next to the 7x squared, and I put the 3 next to the negative 3. I did that just so that it would come out nicely, but it'll come out either way. Either way it'll work. All right, here I have a GCF of 7x. Here I have a GCX of negative 3. Pull out my x plus 1 and write what's left in the other. And I'm going to solve. I get a negative 1 there. And I get a positive 3/7 there. And I solved it. Okay, number 25. Write an equation for a line passing through this point. I'm going to name him x1, y1, and parallel to this line using point-slope form. Well, point-slope form is y minus y1 equals m times x minus x1. That's point-slope form. Okay, I need a point and a slope. Well, I have a point. Now I need a slope. We want to be parallel to him. Just so happens his slope is negative 6, and if I want to be parallel, I keep it the same slope. Okay, so y minus 4 equals negative 6 times x minus 3. There we go. Easy enough. All right, 26. Write an equation for the line passing through x1, y1 and perpendicular to this line using point-slope form. Okay, so as you can probably guess, depending on which version of the test it is that you get, you could either get 25 or 26. Okay, we have our point, we need our slope. Now this slope is 5, but I don't want 5. If I use 5, I'm going to be parallel. I want to be perpendicular, so I'm going to do 2 things to it. First thing I'm going to do is change the sign. He was positive, so I made it negative. Second thing I'm going to do is flip him. He's 5 over 1. I'm going to make him 1 over 5. So take note, I did 2 things. Now I'm going to go in, fill in the numbers, and there's my perpendicular slope. Okay, 27 says use the graph to find the indicated function value. So you're going to have a little graph. This wants you to find f of 16. So remember, this means x is 16. What is y? That's what that means. Okay, so this picture, unfortunately, doesn't have tick marks of 1. It has tick marks of 4. You're not going to have this, so you don't have to worry about it. Yours is a really nice one, I think. Okay, here we go. So I go to where x is 16. Oh, good grief. I go to where x is 16. Okay, and then here's my dot. And then I go over, and my y happens to be 8. And there I go. Okay. Okay, now back to chapter 4 a little bit. We have these problems that involve compounding interest. Okay, so again, depending on what test you get, you could have 1, 2, 3, 4, 5. There's 5 problems represented on this page. Okay, so it's going to give you the formula. round to 2 decimal places, find the accumulated value of an investment of $14,000. That's your principal. Invested at 12%, that's a huge rate. Remember, divide by 100, that's 0.12. Compounded monthly, that gives you our N. What is our N for monthly? 12, because there's 12 months in a year. And our T is 9. Now I'm just going to plug it right in. I'm going to have 14,000 times 1 plus R over T, 0.12 over 9, times 12 times 9. Okay. Remember, we take it one step at a time. 0.12 over 9. Now, depending on where you round here is going to really, really vary your answer. So just do your best, making sure that you check out all possible answers. So I rounded here to the 5th decimal place. Why? I don't know. I just did. So in my calculator, if I do this to the 108th power and hit enter, times 14,000, I'm going to get 58,509.35 cents. And that's going to be my answer. Okay. Now, this stays the same for 4 versions of the test. One version has an N of 12. What would N be for semi-annually? 2. What about for quarterly? 4. And then this is strange. What about for annually? 1. Okay, so the only difference in these 3 versions is that where you put in your N, okay, where you put in your N, it's going to vary greatly with your I just found a huge error, folks. No wonder that came out so crazy. That's supposed to be an N down there. Sorry. No wonder that came out so strange. I kept looking at that and looking at that earlier. Well, this is why you don't make study guides and hand them out so quickly, right? This is supposed to be an N down here. So this becomes a 12. Okay. What's 0.12 divided by 12? 0.01. Okay. This is 1.01 raised to the 108 power times 14,000. Okay. You should have $41,004.96. Good gracious, I'm sorry. I will make a note. This is also a mistake that I've got to look into. Okay, so there we go. I had a mistake on your formula up there. That's supposed to be R over N, and then it's also N to the T. So depending on which N you have, this number and this number are going to go and become that N. So make sure that you are comfortable doing that and that you know how to get the right answer on those, okay? All right, now, if it tells you it's compounded continuously, this is your formula. We don't even have an N. Your P is 5,000. Your rate divided by 100 is 0.056. And your T is 3. Okay, plug that in. We have 5,000 times E to the 0.056 times 3. Okay, put that little guy in your calculator. And you should come out with $5,914.68. All right, here we go. Okay, number 30. The manufacturer of a CD player, I know you guys don't even know what that is, just bear with me, it's an old test, has found that the revenue in dollars that's like the profit, is this equation, okay, a parabola, when the unit price is P dollars. If the manufacturer sets the price, P, to maximize the revenue, what is the maximum revenue to the nearest whole dollar? Okay, all right, what this wants you to find is the vertex of the parabola. Okay, that's what it wants you to find. So it wants you to find the vertex. Here we go. A is -5. B is 1,280. All right, so 2 steps to this, because remember, your vertex looks like this. This first step is going to be -b over 2a. Okay, so first step is going to be opposite of b over 2 times a. Put that in your calculator and you come up with 128. Okay, then you're going to put in 128 for p and solve. Okay, so now you're going to have r of 128, which is going to be -5 times 128 squared plus 1,280 times 128, positive 128. That's going to give you a revenue or a profit of 81,920. And that's your answer. That's what they're looking for. So you're finding the vertex, but this y coordinate of the vertex is your answer right there. Okay. All right, 31. The owner of a video store has determined that the cost, C, in dollars of operating the store is approximately given by this, which is a parabola. X is the number of videos rented daily. Find the lowest cost to the nearest dollar. Now, some of the tests are going to say, find the number of videos. I actually think it's pretzels, but that's what that'll be. And then some of those are going to say, find the cost. So it really just depends. Again, this is a vertex. Okay, this is a vertex. This is going to be the number of videos or pretzels. This is going to be the money. Okay, and you're still going to have to use the opposite of B over 2A to find this. So opposite of B over 2A is going to be a positive 60 over 2 times 3. That's going to end up being 10. So if they want the number of videos or the number of pretzels, it's this first number. It's the x coordinate of the vertex. If they want the cost, that's when you're going to have to put that number in and evaluate it, and you're going to end up getting the cost. Okay, which happens to be what this particular one wants in this case. Okay. All right, let's see. I think I'm going to have to stop at this point and come back and finish the very last few problems. So I'm going to pause here. We'll do the video in 2 parts. This will just be 1 through 31, and then we'll do the last 10 in the second group. So I will be back.